All right, so today we're talking about special segments in triangles. So everything that we're talking about is a segment today. So goal number 1, I can apply the definition of a perpendicular bisector of a triangle. Goal number 2, I can apply the definition of an altitude of a triangle. And goal number 3, I can apply the definition of a median of a triangle. So these 3 things are all special segments in triangles. All right, so first off, it says, what do you think of when you hear the words perpendicular and bisector? So first off, let's talk about perpendicular. When I tell you that 2 lines are perpendicular, what do you know from that? You know that you must have right angles. So that's what the perpendicular part's going to give us. It's going to give us right angles. What about the bisector part? When I bisect something, what do I get from that? When I bisect something, I get 2 congruent parts. Now, these are going to be 2 congruent segments because it's a special segment. So you're going to get right angles in 2 congruent segments, 2 congruent pieces. All right, so what about the perpendicular bisector of a triangle? So here's the definition. A perpendicular bisector of a triangle is, it's a line or segment, it could be either or, that passes through the midpoint of a side of a triangle so that the segment is perpendicular to that side. So let's sketch one. Okay, now this is going to be a sketch. We're not going to get any special tools out, meaning we're not going to use a compass or a protractor or anything to help us get this done here. We're just going to do a sketch of it. So it says y is the midpoint of LE. So first off, is it showing that y is the midpoint of LE? No, it's not, because I don't have 2 congruent parts. So let's go ahead and put in our 2 congruent parts. Now it says draw the perpendicular bisector AY. So notice y is already there. I'm going to do the perpendicular bisector in red. Now I want it to be a segment, okay, that comes up, and I'm sketching it in right now like I'm really sketching, okay? And what's going to happen is that's going to hit the other side of the triangle, and it doesn't have to hit at the vertex, and that's what people want it to do, but it doesn't have to, because what I'm trying to do is I'm trying to put A somewhere over here, and I'm trying to make a straight line right here that's vertical to this horizontal line right here. So I want to make right angles right there. So I know that the iPad has the ability to make straight lines. So what I'm going to do, let me put that tick mark back in there. What I'm going to do is I'm going to just hold it. Okay, that didn't work. Let's try that again. I'm going to just hold that straight line. Why is it not working? Let's try going the other way. Straight line. There we go. Okay. And I'm going to try to make it as perpendicular to that other piece as possible. Now, because I tried so hard, it's not touching Y anymore. Okay. So there is my perpendicular bisector. Now, if I asked you if this is a perpendicular bisector, the answer is no right this second, because I'm not showing that those 2 lines are perpendicular. To show the 2 lines are perpendicular, I need a right angle. So this red piece right here, which is AY, is my perpendicular bisector. So, summary of this, a perpendicular bisector gives us 2 things. A perpendicular bisector gives us right angles. And notice I say right angles because this is also a right angle, but I don't have to draw both boxes in there to imply that they're both right angles. And 2 congruent segments. Okay. All right, so let's try some examples using perpendicular bisectors. Now, this is the shorthand way of writing perpendicular bisectors, just so we remember that. All right, so it says in triangle BIN, AR perpendicularly bisects IB. Find X, Y, and BN. So I have to say, is it showing a perpendicular bisector right now? The answer is no, because with the perpendicular bisector, I need right angles and 2 congruent segments. So it says AR bisects IB. So I'm going to perpendicular bisect IB. IB is at the bottom right here. I need to cut it into 2 congruent segments. So I'll start by doing that. And then I also need to show that AR and BIB are perpendicular so that they form right angles. All right, so I need an equation to solve for x or to solve for y. I'm going to start by writing an equation to solve for x. So I notice that there's an x here, here, and here. Now, I'm not going to use all three of these because this side right here, I don't know anything about it. But what I do know is that these two pieces are congruent. If those two pieces are congruent, I can set them equal to each other to solve for x. I can balance my equation by subtracting 3x from both sides. I have 7 equals 4x minus 17. I'm going to add 17 to both sides. I have 24 equals 4x. And then I can divide both sides by 4. And I have x is 6. So that's one of the things that I was asked for. Now I need an equation to solve for y. So I notice this is the only thing with y in it. And I say, okay, well, what do I know about that angle? I know that angle is 90 degrees. So to solve for y, I can say 9y plus 9 is equal to 90. Subtract 9 from both sides. 9y is equal to 81. And then divide both sides by 9. So I get y equals 9. All right, so let's see. They asked me for x, check, got that, got y. Now I need bn. So now I need to see what bn is. Well, there's bn. bn is this piece right here, right? That I said, what am I going to use that for? Well, I'm going to use x to find bn. So I'm going to do 2 times x, which was 6, plus 5. So that's 12 plus 5, which is 17. So bn is 17. And that's it for that problem. Okay, so now we have one that you want to pause the video and try this one yourself. See how you did. Okay, so you can fast forward through this if you got x is 11, y is 1, and mi is 27. If you did not get those, let's look to see where you made a mistake. So I see that line EC, so notice it goes through the whole entire triangle this time, but still doesn't matter. It can be a line or a segment. Bisects HI perpendicularly. So perpendicularly bisects HI. So I'm going to go to HI and I'm going to bisect it. I'm going to cut it into 2 congruent parts. And I'm going to do that perpendicularly. So I'm going to start by solving for y first because these two pieces are equal. So I'm going to do 15y minus 1 is equal to 6y plus 8. I'm going to subtract 6y from both sides. I have 9y minus 1 equals 8. I'm going to add 1. And then I'll divide by 9. And I get y is 1. All right, now I need x. And I say, okay, I can see that this right here, this angle is 7x plus 13. And I also know it's 90 degrees. So I'm going to do 7x plus 13 equals 90. I'm going to subtract 13 from both sides. I have 7x is equal to 77. Divide by 7, and I get x is 11. Last but not least, it asks me to find mi. So mi is right here. That's this side. So I'm going to need to plug in x and y. So I'm going to do 2 times x, which was 11, plus 5 times y, which is 1. So that's 22 plus 5, so mi is 27. Okay. Next, we have our next definition. So we had a perpendicular bisector. Now we have a median. So where have you heard the words or the word median before? Where have you heard the word median before? There's 2 places that I'm thinking that you're thinking of. Like when you think of mean, median, mode. What is median? A median is when you take all of your numbers and you line them up from smallest to biggest, and it's the one right in the middle. I know a lot of you don't have your driver's license yet, but another time you see the word median is when you're driving down a highway, there's a median in the middle of the road. So notice I use the word middle twice there, and that's exactly what a median is. It's a segment that goes from a vertex of a triangle to the middle of the opposite side, to a midpoint. So it's going to go from the vertex to the midpoint. So let's sketch some of them. There's 3 medians in a triangle. There's 3 perpendicular bisectors in a triangle. But we only drew 1 last time. Let's draw all 3 this time. So here it says, in triangle ADR, LI and P are midpoints. Draw the 3 medians. So I'll start with median DP. I'm going to go from the vertex D to this midpoint P. And I'm going to show that I have 2 congruent parts. That's a median. So notice no right angles. You can tell this because this is obtuse, this is acute, right? But also because there's no right angle right there. All right, let's draw another median in a different color. Let's draw median AI. So we're going to go from vertex A to midpoint I. And then these 2 pieces are congruent. Notice I used 2 tick marks instead of 1 because it's not those 4 pieces are congruent. It's just those 2 pieces and those 2 pieces. Last one, I'm going to do LR. Ooh, that was a little, there we go. 3 tick marks this time. And there we have our 3 medians drawn, okay? So what you need to know is what a median gives us. A median, since it goes to the middle, it's going to give us 2 congruent segments. Notice it doesn't give us any right angles, and notice it has to come from a vertex. If we look back up at perpendicular bisector, this does not have to come from a vertex. Could it? Yes, but the triangle would have to look like this. You have to look isosceles. And then if it went like this, that is also a perpendicular bisector. But it doesn't have to go to the vertex. Okay. Before we move on to examples, let's get our last vocabulary out of the way. This is an altitude. Okay, where have you heard the word altitude before? So some of you might be saying that, well, I've been in an airplane before and I've heard the pilot come on and say, ladies and gentlemen, we are flying at an altitude of, and then fill in the blank there. Or if you've ever been to a mountain, if you've been climbing up a mountain before, it'll tell you the altitude. The altitude is the height that the plane is flying at, or the height of the mountain. So altitude is height. Altitude in a triangle is a segment going from the vertex, and then it's going to hit the opposite side perpendicular. Because when we measure height, if I say how tall am I, if I'm leaning, you're not going to measure from the ground to my head. You're going to measure how long I actually am, okay? So same idea here. In altitude, you need to be perpendicular and be standing straight to get your height, okay? So let's sketch some. We're going to draw them separately in triangle. We're going to draw altitude AP. So we have to come from A, and we're going to hit the opposite side perpendicularly. And that doesn't look very perpendicular. There we go. Okay. So we're going to hit it perpendicularly. Now, am I showing that it's perpendicular? No. So I need to do something to show that it's perpendicular. I'm going to put it in a box there. I can put it in there, or I can put it right here. It does not matter. Okay. So now that piece right there, AP, is an altitude, okay? Now, what if my triangle looked like this? This is triangle WAJ, and I wanted to drop a perpendicular side from A. So if you notice, if I go to drop something perpendicular to WJ, it's on the outside. So sometimes your your altitude is on the outside of your triangle. So an altitude, summarizing us here, an altitude gives us right angles. So an altitude gives us right angles, a median gives us 2 congruent segments, and a perpendicular bisector gives us both. Okay, next thing that I want you to notice is problem 3 and problem 4 look identical. The diagrams, look at them. They look exactly the same. Why would I give you the same problem twice in a row? I didn't. Notice I say in this problem that it's a median, and in this problem I say it's an altitude. So 2 different things are going to result from that. So let's start this first one here. Find the value of x and Li if Ly is a median. What does a median give us? It gives us 2 congruent segments. So in my diagram, I have to mark my 2 congruent segments. All right, Ly is my median. So it comes from L, hits the midpoint of Y, and then I have my two congruent segments. Okay, so what does that mean? If those two are congruent, it means that this is equal to this. So I have 6x plus 13 is equal to, Hank, bud, stop. 15x minus 5. Sorry, dog looking out the window. Okay, so now I need to balance my equation. I'm going to subtract 6x from both sides. I have 13 equals 9x minus 5. I'm going to add 5 to both sides. I have 18 equals 9x, and then I'm going to divide by 9, and I have x is 2. All right, so there's x, and now it also says find Li. Li. So if I look to see where Li is, you went to the other window now that I closed that one. Li is 8 times x, so I'm going to do 8 times 2. So Li is 16. Okay? All right, so I got from this diagram x is 2 and Li is 16 if Ly is a median. But what if Ly is an altitude instead? So what does an altitude give us? An altitude gives us right angles. So an altitude comes from the vertex, hits the opposite side, it makes right angles. So this is a right angle and this is a right angle. You can draw both in or you can draw one in. So the first thing people will say to do is set these two equal. But guess what? They're not equal to each other. That's only if it's a median or a perpendicular bisector. So instead, I know that this angle right here is 90 degrees. So to solve for x this time, I'm going to do 9x plus 9 equals 90. Subtract 9 from both sides. 9x is equal to 81. And then divide by 9. So this time I get x is 9. Now I need to find Ly. Ly is this piece, sorry, Li. Li is this piece right here. So I need to do 8 times my x value of 9. This time I get Li is 72. So notice by changing your vocabulary word, you're changing the problem completely. So to summarize here, it's very important to know your vocabulary. Okay, so we have a couple more left here that are straightforward practice. So if you want to pause the video and try this one on your own, do it. Okay, this one says DV is a median. So what does a median give us? 2 congruent segments. So comes from the vertex D, hits the midpoint V, and gives me 2 congruent segments. So this one says find x. Okay, so I know that this tick mark and this tick mark means this piece and this piece are equal. So that's how I'm going to solve for x. 3x minus 1 equals x plus 7. Subtract x from both sides. 2x minus 1 equals 7. Add 1. 2x equals 8. Divide by 2. X equals 4. So I have x. And now they want me to find dA. dA is this piece right here. So I'm going to plug in 4 there. 4 minus 3 is 1. So dA is 1. Okay? So now another important question here is, why is this here and why is this here? These are called distractors. They're there to see if you know what you're doing. They're there to not use them, to make sure you know what you are supposed to use. Okay, last one. AI is an altitude. Okay, so altitude gives us right angles, no congruent segments, right angles only. So it comes from a vertex, hits the opposite side, and it makes right angles. So how am I going to solve for x? I know that this angle is 90 degrees. So I'm going to do 2x plus 4 equals 90. Subtract 4 from both sides. 2x equals 86. And then divide both sides by 2. So I get x equals 43. Now it says to find angle NAC. I'm going to highlight angle NAC in yellow. NAC. So it wants this angle right here. So So to find that angle, I'm going to have to plug 43 into both of those other angles. So I'm going to do 43 plus 9, which is 52 degrees. So this is 52 degrees. And then 43 minus 7, which is 36 degrees. So now to find NAC, I'm going to have to add those two because it's the whole thing. That's 88 degrees. So this angle right here, angle NAC, is 88 degrees. Once again, because this was 52 and this was 36, so the whole thing is 88 degrees. Okay, that's it for today's notes. You can go ahead and rate yourself on how you feel about perpendicular bisectors, altitudes, and medians.